Hello viewers, my name is Asti Kumar Pradhan and I'm one of the assistant professor in CSE department in Arkajan University. And on behalf of this institute, I would like to welcome you all to this online session. The subject that we are going to cover is actually quantitative techniques for management. And it is consist of 15 modules, and one by one we are going to cover each module, and I hope all of you will like it. Thank you. Hello viewers, welcome to this online session on quantitative techniques for management. It is consist of 15 modules, and we have already covered the first module, that is introduction part of the quantitative techniques. So in this session we will cover about the measures of central tendency. What are the different approaches, or you can say measures are there based on which we can you know uh, find the averages, the central part, central tendency. All these things we are going to cover in the module 2. So without wasting any time, let's start the topics, and let's see first what are the different, or what are the content, overall content of this lecture is. So as far as content is concerned, it is consists of 12 points. Starts with aims and objective, then introduction, and definition, what actually average is. All these things we are going to cover in the definition part. And after that we have function and characteristics of an average. What are the different functions based on average? What kind of characteristics, you know uh, all these things are going to cover in the point 4. And point 5 covers various measures of average, like your mean, median, and other approaches based on which we can find the averages. So point 5 is quite, you can say, very vital, because it covers the important approaches or measures based on which we can assess and we can find the average. One of the method is that we are going to cover in 6th, 7, and 8. I mean, in 6th point is arithmetic mean. In 7, we are going to cover the median. What exactly median is? Of course, in both the points in 6 and 7, what are the demerits and merits also we are going to discuss and closely look into it. After that, in 8th point, what are the different partition or positional measures are there for central tendency. That thing we are going to cover in 8th point. Okay. And 9th point is all about modes, and what exactly mode is and how to find the mode. All these things we are going to discuss in point number 9. Point number 10 is about the relational, or you can say relation between mean, median, and mode. How closely they are related to each other. What is the main difference between which exists between these three measures. All these things we are going to discuss in point number 10. Point number 11 is all about the geometric mean. What exactly it is, how it is helpful to find the measure. All these things we are going to, not measure, I can say, it is one of the measures which is helpful to find the central tendency. So what exactly it is, that thing we are going to cover in the 11th point, that is geometric mean. Point number 12 is all about harmonic mean. What exactly harmonic mean is, how it is helpful, and what is the working procedure. So all these things we are going to cover in the point number 12, that is harmonic mean. So let's first check what is the actual aim and what are the objectives that can really help the learners, or you can say students, to learn the concept in the better way. That thing we are going to start quickly. Okay, so let's go to the next slide. So the purpose of this lesson is to introduce students, or like you guys, learners, to the concept of measures of central tendency, which are used to what summarizes or summarize and describe the center of the data set. Data set can be very huge, consist of number of data points, and it is very vital, or I can say important, to find the central value, or I can say the average value based on which we can judge or identify about the data set, whether my data set is appropriate or not, how the data points are scattered or closely or correlating, or you know they are correlating with each other. All these things we can find based on the average value or the on the centric value, right? So after studying this topic, students or learners will be able to define the concept of average, what exactly average is, how to define average, what in real world what exactly average is. All these things the student or learners will be able to understand and can be able to define. After that, these learners will be able to understand different measures of averages, like what mean, median, mode. All these things the student will learn in the with the help of the upcoming videos and in the, I can say, upcoming lectures. After that, we have what? I mean, they can also learn how to calculate the various averages. What is the actual procedure? What are the different steps that they will have to go on through? All these things they will have to, go through. All these things will be covered, and the students will be able to know. Finally, they will be able to recognize the importance and difference that actually, between the different types of averages, how they are correlating and relating with each other. What is the difference that exists between these different measures? All these things they will be able to understand and they can able to recognize. So this is all about the aim and objective that the learners they are going to achieve and they are going to get. After that, let's understand little bit about what actually central tendency is. Okay, so the study of central tendency is a fundamental part of statics. Previously also we have discussed in the first module about a little bit about statics, what exactly it is. And statics, as I previously said, in the previous videos, statics is all about collecting and analyzing the data in order to find the pattern that exists between the data points, in order to what? In order to actually extract the information that exists between the data points. And based on the data, information, what it helps to take the better decision for any organization. In order to make a good and better decision, I think information, good and amount of and correct information is required. And to extract that information from the pattern based on the data set, statics are different statistical methods are used to extract that information. So central tendency is what? It is the fundamental part of the statics. Okay, now it deals with finding a single value that best represent a set of data. It deals with what? Finding a single value. Based on the single value, now we can represent the whole data set or the set of a data, right? And summarizing the data's general trend. What kind of trend? How the data, based on the data set, what exactly, whether they are increasing or decreasing, what kind of trend which actually exists, it also help to summarize that, right? So measures of central tendency are widely used in statistical analysis to get an idea of the overall pattern of data points in a data set. So generally what I have said this already, that for analyzing the data, that also based on statistics, measures of central tendency are used. Okay. Next is, now what is definition actually is. So the average of definition or definition of the average. So next is what exactly average is. So the average of a distribution has been defined in various ways. Some of the important definitions are given by different what I can say, different individuals, like according to Clark and Sackett, what exactly they quoted or they said that about, average An average is an attempt to find one single figure to describe the whole of figures. So they are pointing that out of many data points or data set, how can you, based on the single measure, based on the single value or figure, how can you describe the all over or the whole data set? That is what they are trying to, based on their definition, that is what they are defining. An average is an what? Attempt to find one single figure to describe the whole of figures. Based on the single figure, you are able to define the whole of figures. That is what, according to Clark and Sackett, average is. Now, another definition provided by Murray R. Spiegel, average is a value which is typical and what representative of a set of data. So it is a value which is the representative of a set of data. Based on one value, you are going to represent the whole data set. That is what Murray is trying to define. Okay. Now, the third definition that has been given by Cortex and Cowden, according to them, an average is a single value within the range of the data that is used to represent all the values in the series. Okay. So it is nothing but, according to them also, it is a single value that is also what, within a range of the data that is used to represent all the values in the series. Based on one series, with the help of a single value, how can you represent the overall all the data values? That is what average is. By using average, now we can able to represent all the values in the series. Since an average is what, somewhere within the range of the data, it is sometimes called a measure of central value. That is what, according to what according to Cowden and Roxton. Okay, that is what the definition that has been given by them. Now, what are the functions and characteristics of an average? How can you characterize an average? That we are going to learn right now with the help of this slide. The main functions and characteristics of an average includes, first point is what? To present huge mass of data in a summarized form. Okay. Now, you have huge amount of data. Now, it is very difficult, let me tell you, to handle huge amount of data. So summary is required in order to explain the data or the overall data set in a better way. Now, to summarize that data in a, to summarize, to get that summarized form, average can play a vital role. It is very difficult for human mind to what? Grasp a large body of numerical figures. A measure of average is used to what? Summarize such data into a single figure. So out of many, based on one, you are going to define all. That is what average value is. Now, second point is what? To facilitate comparison. To comprise or to make comparison between the data points, between the data sets, I can say average is required. So different sets of data can be compared by comparing their averages, right? So one data set can be compared with the other data set based on the average value. Based on the average value. For example, second point is what? To facilitate comparison. Now, two data sets are there. How can you compare two different data sets with each other? So for that purpose, average can play a very vital role. To compare different data sets among with each other, average can be used. Based on the average value, we can compare the data set with each other. So different set of data can be compared by comparing their averages. For example, the level of wages of workers in two factories can be compared by mean or average. Okay, wages of averages in each of them. Okay, based on which we can compare it. Second, to help in decision making. Average is very helpful for decision making as well, which is the actual reason behind the quantitative techniques. Quantitative techniques, in the previous lectures also I have explained this, that to take better decision and for decision making, quantitative techniques are very helpful. So to help in decision making, average values are actually used. Most of the decisions to to be taken in research, planning, etc., are based on the average value of certain variables. Okay. Now we have discussed few of the functions of averages. Now it's time to discuss some of the characteristics of average. So what are the possible characteristics of an average? I think the first point is like it should be uh, defined perfectly by an algebraic formula, so that different persons obtain the same value for a given set of data. Okay, rigidly we can define. So for this should be the what I can say, one of the important characteristic based on which we can say that it is a average. We can easily what, based on the average we can easily take the better decision. Second, it should be easy to compute. Computation, if it will be difficult, then ultimately it will leads to what? Wrong result, lengthy process, time consumption will be very high, and time is all about money. So to save time, it should be easily computed. So it should be easy to compute. It is one of the characteristics. Okay. Next, it should be easy to understand, because if it will be not easy to understand, it will be difficult for any person to what, to make the current decision. So it should be what, easy to understand. Next, what, it should be based on all the observation, because based on the data point, based on the observations, we are going to find the average. So if such observations will be not there, then it will leads to the failure of the, or I can say that we are going to get the wrong value. So it will be based on some observations. So these are the some what I can say characteristics of an average. Next one is, let's discuss some of the measures of actually um, now let's discuss some of the measures of your central tendency, and as I have already mentioned in the content part, one of them is your arithmetic mean. Okay, now the what exactly it is, let's understand first. The arithmetic mean, also just we can call it as mean, is the most commonly used measures of central tendency. It is the most commonly used measure. Okay, it is calculated by summarizing or summing all data values and dividing the result by number of data points. So suppose we have 10 data points or 10 different value in the form of x1 to x10, then what will be the what, how can we find the mean? In that case, first we will have to add all the 10 values starting from x1 to up to x10, and then it will be divided by the total number of values. Now here how many values are we are adding? We are adding 10 values starting from x1 to x10. So what will be the equation? The arithmetic mean equation will be summation of x divided by n, and represent here the number of values in the data set, and summation of x is the sum of all data values. Okay. Next, so this is one of the example of arithmetic mean. Uh, and two approaches I would like to explain you here. One will be the direct method, another will be the shortcut method where deviation is used. So suppose, as you can see here, different values or outputs are mentioned based on the month, different month starting from January to December. That means what? Total 12 number of values are there. So for n, the value will be what? 12. Now to find the mean value, what we will have to do? We will have to add all the 12 values starting from 82 up to the last value for December is how much? 86. So we are going to add one by one values starting from 82, the last value which is 86. Okay, and the overall, the total value will be divided by the number of values that is present in the data set, which is what? 12. So finally we are going to get 91.5 as the mean value. So this is what the direct method is, where all the values are simply added and by the divided by the total number of value. Second approach or method is the shortcut method, where we are going to take the deviation value. Let's say here A is the here we are going to represent the deviation part by using A, and the deviation value we are taking, suppose let's I mean 90. So now what we are going to do, deviation is required whenever the magnitudes we are is very high. So in that case, likewise, as you can see in the slide, it will be what? If xi is the what I can say, different forms of value, then di will be, deviation will be xi minus a. Okay, so likewise we can find finally the total will be added up and it will get what? It will give you the mean value, which is what? In this case 91.5. okay, you can easily calculate, as you can see, 80 minus 10, sorry, xi is how much? 80 minus a, the value of a is what? 90. So we are going to get minus 10 for the first point, that is for 80. Likewise we are going to get for up to 86. Okay, then you have to add all the deviation part, you will have to sum up them, and for that what you are going to get 18. Okay, the not mean value, I can say the total value in the form of deviation is going to be 18. So 90 is the deviation value plus 18 by 2. 18 is the mean value, not mean value. 18 is the summation value, sorry. So 90 plus 18 by 12, that is going to give you 91.5. So here are some of the merits of arithmetic mean. Arithmetic mean is defined by rigidly, defined by an algebraic formula. So formula I have already mentioned there in the previous slide, summation of x divided by n. So if you are going to represent the mean value with the help of x bar, so x bar will be equal to what? Summation of x divided by n, which is nothing but total number of values. Now, calculation of arithmetic mean requires simple knowledge of addition, multiplication and division of numbers, and hence is easy to calculate. So if you have the knowledge regarding addition, multiplication and division, you will be able to find or calculate the mean value. It is capable of finding treated mathematically, and hence is widely used in statistical analysis. So it is one of the measure for central tendency, and it is generally used for what? It is widely used in statistical analysis as well, to find, to extract the information, to overall judge the data set. By finding the mean value, we can check how much the other data points are placed, what kind of distance they are maintaining, how they are scattered. Based on the mean value, we can find and track that. Now, what are the possible demerits of arithmetic mean? So, although arithmetic means satisfies most of the properties of an ideal average, it has certain drawback, and should be used with care. Some demerits of arithmetic means are as follows: like it can neither be determined by inspection nor by graphical location. So unless and until you will find the average, it will be very much difficult for you to graphically locate it. Okay, next point, what arithmetic mean cannot be computed for qualitative data. So for quantitative data you can easily find, but when it's come to qualitative data, it is very, what I can say, difficult to, I mean, you can say you are unable to find the mean value, like data on intelligence, honesty, or smoking habit, etc. So you cannot find that, isn't it? So these are some of the examples are also mentioned here. Uh, Third point is what, it is too much affected by extreme observation, and hence it does not adequately represent data consisting of some extreme observations. So it is too much affected by what? Extreme observation. Rigorous and extreme observation is required, because calculation part is much required here in order to accurately find the mean value. So it is, I mean, it does not adequately represent data consistent. Okay, so that's what through this point I'm going to, so that is what through this point I'm trying to explain. Next measure is for central tendencies. Now next measure for central tendency is median. The median is the middle value. Now the next measure for central tendency is median. The median is actually the middle value in the data set, and when it is ordered from smallest to larger or vice versa. It can be from smaller to larger, or it can be from opposite as well, from larger to smaller. So to find the middle value, so the middle value I can say is what? Is actually the median. If there is an odd number of values, the median is the middle value. If there is an even number, the median is the average of two middle values. Okay. Now, what are the steps which are involved in order to find the median value? So first you have to arrange the data in ascending or descending order, as simple as it is. Second, if the number of data point is odd, then median is the middle number. So if suppose the number of values are, or in the data set are, suppose 11, so five partition will be there. The sixth index value will be the middle value. So it will be the median value as well. If the number of data points is even, the median is the average of two middle values. So whatever will be the average of two middle values, that will be the median. The median is not influenced by outliers, which make it a better measure for distributions. This is one of the example that I have taken from one of the book. Let's discuss some of the one of the example of well, let's discuss one of the example of median. This is one of the example that I have used here in this presentation. This is this example is one of the is one with the help of which we can easily understand the concept. Right now, as you can see, it is consist of 7 data points or 7 values starting from 20 to 30, and what exactly median is? It is the middle value. Okay. Now, one important condition here, which I have already explained, that the order must be in a ascending order or it should be in a descending order. So suppose I am making it in ascending order, we get 15, 16, 18, likewise up to how much? 30. Since n is 7 here, that is odd. Now median is the size of what I said, size of 7 plus 1. Now, what is 7 plus 1? 7 is what? The total number of data points is 7, as you can see, 20, 15, 25, 28, 18, 16 and 30. That means 7 plus 1 divided by 2. So that is how much? Fourth observation. Now, what is the fourth observation here according to the this pattern or this sequence? You can see the fourth observation is here how much? 20. So the medial value or according to the result or observation, the here the median value will be 20. Okay, the same value of MD will be obtained by arranging the observation in descending order of magnitude. If you will arrange it in descending order also, you are going to get the same. Okay, so this is what exactly how you can find the median value. If it is in odd format, if the number of the sequence is odd, in that case you will have to, this is how you can find, like here it is odd, so 7 plus 1 divided by 2, so it is how much? Fourth observation, which is what? 20. Next is, what are the merits of median? So it is easy to understand and easy to calculate, okay, especially in series of what? Individual observations and ungrouped frequency distribution. Okay, in such cases it can be even be located by inspection. So usually you can locate it as well by inspecting or by finding or looking into the data set or sequence. We can easily what? Locate the median value. Second, median can be determined even when class intervals have open ends or not of equal width. If the width is also not equal, even in that case also we can determine uh, when class interval have open ends, right? So this is one of the merit of what? Median. Next is what? It is not much affected by extreme observation. So if the observation is rigorous, then also it is not going to be affected, because we can easily by inspecting the value or by inspection also we can what? Find the median value. It is also independent of range or dispersion of the data. So it is independent of the range. So it is easy to what? To find. It is not affected by the extreme observations. Okay. Now, median can be also located graphically. This is one of the major advantage which was not there in case of your other measures. But here you can graphically locate the median value. Okay. Now, what are the demerits of medians? One of the demerit is what? In case of your individual observations, the process of location of uh, median requires their arrangement in order of magnitude, which may be a cumbersome task, particularly when the number of observations is very large. So for large observation, if the data set is consists of huge number of data points, in that case what you will have to arrange them in a proper order, whether it can be whether it will be in a ascending order or descending order, but anyhow you will have to arrange them in a order, then only you will be able to find the median value or middle value, right? It doesn't matter whether it's odd or even in terms of number, but you will have to arrange them. And for larger data set or larger data sequence, it is very difficult, very rigorous process. So it is one of the demerit of median. Second, it being a positional average, it is not capable of being treated algebraically. Okay, based on algebra or algebraically, it is not capable of being treated algebraically. Okay, it is a positional average, so algebraically it is little bit difficult. Okay, next point is what? uh, in case of individual observation, when the number of observation is even, the median is estimated by taking mean of the two middle most observations out of I mean, you can easily locate it by taking mean of what? Of the two middle most observation, which is not an actual observation of the given data. Okay, this is one of the demerit. Fourth one is what? It is not based on the magnitude of all the observation. It is not based on the what? Magnitudes, the values, okay, of the observations. So it is one of the, what I can say, demerit which actually put it in a danger zone. Okay. Now other measures based on which you can uh, now others measure now other measures of central tendency are, you know, some of the uh, methods based on partition and positional. So other positional and partitional measures are like quartiles is there, percentiles are there, declines are there. So what exactly quartile is then? Divide the data into 4 equal parts. The first quarter or quartile is the median of the lower half of the data, okay, and the third quartile is the median of the upper half. The interquartile range IQR is the difference between QR and Q3. After finding Q1 and Q3, you will be able to find the IQR, which is the interquartile range. Okay. Now percentiles are what? Divide data into 100 equal parts. Whatever sequence you will get, or whatever data points, or whatever data set you will get, based on that you will have to divide the data into 100 equal parts. The data value which is present at the 50th percentile is the 50th percentile, I mean to say, is the what? Median value. Okay. Now all these things we will discuss. I mean, you will have to little bit, you will have to practice these things also. Just briefly I am explaining this, but you will have to go through some of the examples to know more regarding these things. Declines, divide the data into 100 equal parts, okay, and based on that you could be able to find the declines. Now discuss some other forms of measures based on which we can find the central tendency, and what can be the possible ways. So based on partition and positional measures, we can find or determine the central tendency. Okay. Uh, Partition or positional measures help describe the distribution of data, right? How the data are or inside the data set or based on the data set are distributed. All these things we can find based on the partition and positioning or by positional measures, right? So what are the possible measures are there in this I mean as far as this category is concerned? So first one is your quartiles. Okay. Now if you have the data set, and what you can do, you can divide the data into 4 equal parts. Okay. Now these parts, each part will be considered as, it can be anything, it can be even, it can be odd, but you will have to divide them sequentially into 4 different parts. So quartiles, divide the data into 4 equal parts. Suppose you have the data set, what you will do? You will divide it into 4 parts. Now each part will be considered as what? As the quartile. The first quartile is the median of the lower half. What it? Of the data set. Median of the lower half. And the third quartile is the median of the upper half. Different parts, what you are doing? You are taking the data and you are dividing it into the equal halves, 4 equal halves. Okay. First quartile is what? It is also the median value. Okay. Median of the lower half of the data. And third quartile is the what? Median of the upper half. For upper half, Q3 is there as the quartile. For lower half, Q1 is there as the median, as the quartile. The interquartile range IQR is the difference between QR and Q1 and Q3. Got it? Now percentiles, divide data into 100 equal parts. In the first case, what we are doing? We are dividing the data into 4 equal parts. Now we are dividing the data into 100 equal parts. The 50th percentile is the median. Ultimately, all are revolving around what? Median's value. So the 50th the 50th percentile is the what? Median value. Then what? Deciles. Divide the data into 100 equal parts. These measures provide additional insights into the spread and variability of data. Okay, how the data is actually scattered, and what is the variability, all these things we can find based on the partition and positional measures. And for these what I can say task, we have different form of measures, and the measures are like quartiles, then percentile and deciles. Now let's discuss what exactly mode is. So we have already covered like mean, then median, some of the demerits of mean, merits and demerits of mean and median. Now it's time to discuss about the mode. So what exactly mode is? So mode is the value that appears most frequently in the data set. Okay, a set may have what? One mode. So we call it as unimodal. Okay, so a data set with one most frequent value. The values, suppose we have the data set of 5 values, and 5 values are like 1, 2, then 3, then 2, then 4. Okay, so any value which is frequently arriving, or like 1, 2, 3, 4 and 4. So if this is the sequence, so 4 is what? Appearing more than one time. So it is a frequent value, or like 1, 2, 1, 2, 1. So in this case, what? 1 will be the frequent value. So mode will be what? 1. Okay. So unimodal, a data set with one most frequent value. Now two modes, bimodal, two modes with, we call it as what? Bimodal, a data set with two values that appears with equal frequency. So it is what? Bimodal. Now multiple modes mean multimodal, a data set with more than two frequent values. If it is one, then unimodal. If it is two, then bimodal. If it is three or more than two, I mean to say, then it is multimodal. Now no mode is what? If all values appear with with equal frequency. 2, 2, 3, 3, 4, 4. Likewise, if 6 values are there and 2, 2 is appearing 2 times, 3 is appearing 2 times, 4 is also appearing 2 times, then what? No mode is there. No mode is there, because all values are appear with equal frequency. Based on the frequency, what I am trying to explain here is, with highest frequency, that value will be considered as the mode. Okay, the mode is useful in categorical data where we want to know the most common category. So to identify the category, mode is actually used as the measure to classify, to categorize the data. Okay, now what is what kind of relationship that exists between these three approaches or these three measures, like mean, median and mode? So let's discuss that one now. The relationship between the mean, median and mode can indicate the shape of the data's distribution. Repeatedly and previously also, based on the slides, I am trying to explain you one thing, that in order to take the better decision, we need the data, and to analyze the data, we need the quantitative techniques. Based on the quantitative techniques, what we are doing, we are trying to find the pattern, the relationship that exists between the data points. Based on the relationship, what we are doing, we are trying to find the information, and based on the information, what we are taking the decision. So for better decision making, the quantitative techniques are required. Now, the relationship between the mean, median and mode can indicate the shape of data's distribution, how the data points are scattered, how data how they are relating with each other, how closely they are linked with each other, what is the actual pattern that exists between them. To know these things, we need we need these measures actually. Now, what kind of distribution based on these measures we can find or we can identify? One of them is called symmetric distribution, okay, where the mean, median and modes are equally. You are going to, if you can check in terms of distribution, all the values for mean, median, mode will be equal. Second will be, so we have discussed what symmetric distribution, where the in terms of values the mean, median and mode will value will be equal. Now the second distribution, second kind of distribution is called right skewed distribution. As we have discussed, like in symmetric distribution, the value of mean, median and mode will be equal. Now the second form of distribution is called right skewed distribution, sorry. uh, Now, as we have discussed in the symmetric distribution, that the in terms of, I mean, value for mean, median and mode, all will be equal. Now the this is the second kind of distribution called as right skewed distribution. Here the mean is greater than the median and the median is greater than the mode. So like sequence, mean is greater than the median is greater than the mode. Okay, so that is what what in terms of data distribution. If you go with the data distribution, if you will find the mean, median and mode value, you will come to know that the mean value will be greater than the median value. The median value will be the greater than the mode value. If you will find this kind of sequence, you can say the data distribution is a right skewed type distribution. Okay, now this is what right skewed distribution. Second type is called left skewed distribution, where the mode is greater than the median and the median is greater than the mean. So just reverse order. Here the mode will be greater than the median and the median value will be greater than the mean value. So this is what exactly, in terms of distribution, uh, you will be able to find that in there are different forms of distributions are there, as we have discussed in this slide, like symmetric, then right skewed, left skewed. So in symmetric, all in terms of value for mean, median and mode, all will be in a equal mode, all will be equal. Second will be what, in right skewed, mean will be greater than the mode median value and median will be greater than the mode value. In left skewed, what, just reverse order will be there, where the mode value will be greater than the median value and the median value will be what, greater than the mean value. Okay, so now it's time to discuss geometric mean. Okay, now what exactly it is? So the geometric mean is the nth root of the product of all values. Okay, it is often used when the data involves rates of growth or ratio, such as in finance or population growth. So to calculate the population growth or even in finance category, we need the geometric mean. Okay, so you can see the equation as well. Pi, in terms of I, the value will be start from 1 to n, and pi of xi, where the um, uh, in terms of power it will be what, 1 by n. Xi represent each value in the data set. Okay, the geometric mean is useful when you are dealing with percentage changes or when the data are multiplicative in nature. So for geometric change, or uh, these are actually, next approach is or measure is called geometric mean. Okay, now this mean is actually the nth root of the product of all values, and it is often used when the data involves rate of growth or ratio. Okay, when the data involves some kind of ratio or rate of growth, such as in case of your finance, or suppose for population growth. In these category or in these type of cases, generally geometric mean is used. So the formula for geometric mean, as you can see in the slide, I mean in the screen, it will be in the form of pi, and it will be start with 1 to n. In the ith value will be start from 1 to n xi, and x represent the number of, I mean what, values in the data set. Xi represent what, each value in the data set, and the overall will be what, in the power of 1 by n. So geometric mean is, if you will ask me one thing, uh, where actually we can use. So when you are dealing with the percentage changes, or when the data are multiplicative in nature, in that case we actually use the geometric mean. Okay. Next is harmonic mean. What exactly harmonic mean is? Now, the harmonic mean is the reciprocal of the arithmetic mean. Okay, reciprocal of the what? Arithmetic mean of the reciprocal of the data values. So, okay, it is often used for rates like speed. Okay, where the data values are inversely proportional. Okay, the formula for harmonic mean will be what? N by summation of 1 by xi, where I value will be from 1 to n. Okay, where n is what, the number of values, and xi is each individual value. Okay, so to represent the individual value, actually we are using xi, and for total number of value we are using n as the indicator. The harmonic mean tends to be lower than the arithmetic mean, and is particularly useful when dealing with average of rates of or ratio. In previous case, when you are dealing with percentage values, or the values which are multiplicative in nature, as you can see, then in that case you are using what, geometric mean. But when you are using or dealing with the average of rates or ratios, in that case you are using what, harmonic mean. Okay, so till now we have discussed what, mean, median, mode, some of the partition based measures as well, position and partition based measures as well, and types of means also we have tried to cover, like harmonic mode, harmonic mean, and type of means also we have discussed, like harmonic mean and uh, you know uh, geometric mean. So thank you till now for your patience and for watching this video, and I hope you have got some kind of information regarding the topics. I hope you will like it, and in the upcoming session we will try to discuss some of the topic related to uh, module number 3, and slowly, I mean not slowly, but sequentially we will cover rest of the modules as well. Thank you once again.